Welcome to the channel. Today, our subject of discussion is speedometer, mechanical shock test, and drop test. Before we start the discussion, we would like to request you to please subscribe this channel to improve its reach to the professionals related to automobiles, motorcycles, and scooters. Coming to mechanical shock test and drop test, these are two distinct tests, although they are related in nature and sometimes grouped under the broader category of mechanical durability or handling robustness testing. Here are the details and breakdown to clearly explain the differences and relationships between these two tests. To start with mechanical shock test. What is its purpose? To simulate the impact forces that the speedometer might experience during these four situations. Vehicle collisions occur, mounting or removal impacts, transportation jolts, off-road or pothole induced shock events. ये कैसे किया जाता है? The speedometer is mounted on a shock test table. A controlled pulse or impact is applied in multiple directions, that is X, Y, or Z, often tested by powered or unpowered. Typical parameters of mechanical shock test. The one attribute, shock pulse. It could range between 30 to 50 G. It could be half sine or sawtooth wave. Duration 6 से 11 milliseconds. Number of shocks 3 से 6 per axis or total 18 shocks as per ISO and IEC standard. Conditions with or without power. Drop test क्या है? Drop test का purpose to simulate accidental drops during manual handling, assembly line पर mishandling की सूरत में, and logistics and shippings. This test evaluates the product resistance to free fall impact without mounting or isolation. That is a worst case real world abuse simulation. In case of this drop test, this is freely the speedometer is freely dropped from a specified height onto a hard surface. That could be steel or concrete. It is dropped at multiple orientation, face, side, and corner, etc., etc. Unit is then inspected for visual damage and functionality. Typical parameter in case of drop test. Drop test, drop height from 1.0 to 1.5 meters, depending upon specification. Or surface, that could be steel or a concrete plate. Number of drops, 6, once per face oblique side, or 10 plus in case of in extreme cases. Post checks, post test checks, functionality, cracks, and display damage, etc., etc. The applicable standards are IEC 60068-2-31, ASTM D5276, and finally OEM specifications. Summary of the comparison between these two tests: mechanical shock test and drop test. Test type number one: controlled depth shock, mounted or clamped. Or drop test, it is a free fall, unmounted. Purpose: simulate in vehicle impulse and shocks. Drop test purpose: simulate human handling and logistics drops, etc. Shocks nature: in case of a mechanical test, precise pulses, G-force, duration controlled. In drop test, random, uncontrolled, and real-world impact. Mounting conditions: in case of mechanical shock test, fix on text fixture, and in case of drop test, free fall, that is unmounted. More repeatable: functional test, mechanical shock test is more repeatable as compared to drop test. Failure modes detected: in case of mechanical shock test, internal BCB cracking, connector loosening, and drop test, casing leakage, lens crack, and internal dislodge. Test phases: mechanical test, that is R&D for qualification stages and for endurance testing, and drop test primarily to check packaging, assembly, and to ensure quality audits. Now, our question is, are both these tests necessary? The answer is yes, for full product robustness. Mechanical shock is essential for ensuring durability inside the vehicle, especially under road shock or mounting load. Whereas drop test is important for manufacturing, shipping, and service scenarios where human mishandling is quite common. Let us now proceed to detailed comparative format for mechanical shock test and drop test. Number one, mechanical shock test for analog and versus digital. Objective is to assess the speedometer's resistance to mechanical impact forces it may encounter during vehicle operation, mounting, transport, or collisions. The test setup is: mount speedometer unit securely on a shock test platform. Apply shock pulses along three axes, that is X, Y, and Z. Test with powered on or off for digital units. Monitor for mechanical integrity, operational continuity, and functional recovery. Now let's compare aspect, main concern. In case of analog, needle misalignment, gear damage, odometer missteps. In case of digital speedometer, PCB cracking, LCD damage, loose connectors, and rebooting under shock. The aspect of internal weak points. In case of analog speedometer, coil magnet movement, needle damping components. And in case of digital speedometer, microcontroller, solder joints, display FPC, that is flexible printed circuits, and connectors, etc. Functional checkpoints, that is needle return to zero, odometer counts correctly post-shock in case of analog speedometers. And in case of digital speedometer, display lights up, speed display updates, no software freeze. Shock pulse profile. In case of Analog speedometer, it could be half sine, 30 to 50 G, 60 to 11 milliseconds. In case of digital speedometer, it could be the same, but powered on. Monitoring is critical. Monitoring tools. In case of analog speedometers, visual inspection, mechanical dial comparator. For digital speedometer, CAN analyzer and CAN oil, oscilloscope, boot timer, power cycling logs. Test standards ISO 16750-3 in both the cases, IEC 60068-227 in both the cases, and for digital speedometer plus OEM software performance criterion. Failure modes observed in case of speedometers, it could be bent needle, rattling, and odometer digit skip. And in case of digital speedometer, display blackout, software reset, no CAN communication, and LCD cracked. Post-at validations. In case of analog speedometer, needle sweep smoothness, gear feel, zero calibration. In case of digital, reboot behavior, display integrity, log check, CAN response accuracy. Example test conditions, 3 shocks per 3 axis, that could be 9 in total, acceleration 50 g, duration 11 milliseconds, powered on for digital type during at least one shock in each axis. Now, drop test, analog versus digital. The objective, as discussed before, is to simulate accidental drops or mishandling of speedometers during manufacturing, assembly, servicing, or shipping. The setup, unmounted unit is freely dropped from a defined height that could be 1 to 1.5 meters, dropped in multiple orientation, that is face, side, or corner. Recovered unit is checked for cosmetic damage, display issues, and full functionality. As before, here is the comparison table between analog speedometer and digital speedometers applicable to drop test. Drop orientation, face down, side edge, rear housing, needle facing up and down. In case of digital speedometer, same orientations, more attention to screen and housing. In case of drop test, the aspect of main failure risk. In case of analog speedometers, such as a broken needle, misaligned shaft, and cracked housing. Where in case of digital speedometer, LCD cracked, PCB dislodged, FPC tear, and connector pop out. Visual checks after drop test. For analog speedometer, it could be lens crack, needle deformation, and gear dislocation. Where in case of digital speedometer, it could be screen cracks, loose parts inside, and bezel deformation. To continue with this comparison table, the aspect functional checks. In case of analog speedometer, needle movement, odometer turns correctly. For a digital speedometer, boots up correctly, CAN LIN communication okay, display backlights works. Test height 1.0 to 1.5 meter on a steel or concrete surface. In case of digital speedometer, it is same. Surface steel plate or hard composite. In both the cases, it is same. Failure example. In case of analog speedometer, it could be odometer digits misaligned and needle stuck at midpoint. Whereas in case of digital speedometer, there could be dead pixels, frozen displays, PCB cracked, boot up failure after drop. Now, coming to post-test functional evaluation of both the types, check item, power on behavior. For analog computer, for analog speedometer, it is not applicable. And for digital, must boot without delay or errors. Speed input response. The digital, the analog speedometer needle should move according to the input rotation. Whereas in case of digital, speed digits should update with test signal. Display clarity, visual only in case of analog, and LCD, TFT, or segment display should be clear. Electrical connectivity is not critical for analog, usually no electronics. Whereas in case of digital, connectors and solder joints must be checked. Internal noise. Rattle sounds indicate gear or PCB damage. In case of digital, rattling means loose board or broken housing. The factor of mounting, mechanical shock test. The speedometer is mounted to fixture. In case of drop test, it is unmounted and free fall. Impact control, precisely controlled, that is G and time direction. In case of digital, in case of digital drop test, randomized rearward shocks. Repeatability. Mechanical shock test is a highly repeatable and in case of drop test, moderate to low. Focus areas. Mechanical shock test, it is internal structural robustness, whereas in case of drop test, outer casing, connector, and overall survival. Summary. Mechanical shock test ensure the speedometer can survive weak vehicle jolts, mounting impacts, and crashes. Drop test, it ensures durability during shipping, handling, or accidental drops during service. Now, let us talk about test report templates. A mechanical shock test report templates. Test name, mechanical shock test. Report number, component tested speedometer. Part number, test date, test engineer, test standard, etc. All are recorded. Test equipment used, shock table, DAQ system, oscilloscope, and camera. Shock profile, 50G, half sine, 11 millisecond, 3 shocks per axis, that is X, Y, and Z. Mounting orientation, face down, vertical, and horizontal. Power down during test, yes. No, depends upon type and phase. Going to post-test functional checks. Boot up. It boots up in 1.8 seconds, therefore it is pause. Speed indication accuracy within 2% of input. Pause. Needle stability. Analog. No jitter. This is pause. communication over CAN or LIN. No errors in CAN log. It is declared as false. Mechanical integrity. No cracks or misalignment. It is false. Drop test template. Test name drop test. Report number so and so. Component test is speedometers. Drop height 1.2 meters. Drop surface steel plate. Drop orientation free, back, top, bottom, left, and right. Number of drop 6. Test engineer name and date so and so. And post drop observation, e.g., for example, lens cracked on face drop. Functional check after drop. Boot behavior, digital, booted in 2 seconds, therefore it is pass. Display health, digital, no flicker or dead pixel, therefore it is pass. Needle motion analog, smooth and consistent, considered as pass. Physical inspection, minor scuff, no cracks, pass. Communication digital, plan response okay, it is declared as pass. Test equipment and setup overview. Mechanical shop test. Shock platform, pneumatic or hydraulic actuator with shock pulse generator. Fixture. Customer mounting blocks for speedometer. See orientations. Sensors. Accelerometer, displacement sensor, and DOQ systems capture shock data, that is G-force and duration. Power supply 12 volt or 14.4 volt to power digital units. CAN interface to check communication, post-impact CAN analyzers or oscilloscope. Drop test. Setup. Drop tower or manual drop frame. Platform. Hardened steel or composite tile. Height control. Guide rail or fixture for consistent orientation. Cameras, high speed, optional to capture impact. Visual checklist for damage, crack lens, separation, etc., etc. Number 3. Field failure case studies, analog, digital, analog speedometer, real failures. Real failures are failure types. Needle fails stuck at 40 km per hour speed. Observed issue never return to zero after hard bump. Root cause coil spindle bent due to high G impact. The second failure could be rattling failure, internal noise during motion. Gear came loose after rough landing. Order misalignment, odometer misalignment, digits not aligned in window. Mechanical shock, cracked gear alignment post. Digital speedometer, real failure issues. Failure type, display not turning on. Observed issue, dead after drop from workbench. The root cause, power regulator IC cracked inside. Failure type, flickering at startup. Observed root cause, unstable screen during vibration, and the root cause could be LCD FPC connector loosening after drop. Reboot during driving, sudden restart during pothole impact. The reason could be MCU watchdog triggered from connector dropouts. CAN communication lost, observed issue, no data after drop, and the reason could be board solder joint failure on CAN transceiver. Summary. Mechanical shock test internal durability during controlled impact pulses, for example, simulating on road jolts. and drop test external durability and overall survival when accidentally dropped. Both tests are essential for real-world robustness and cover different use cases. With this, we come to the conclusion of our today's discussion on the subject of speedometer, mechanical shock test, and drop test. We shall appreciate if you share your thoughts too, and if it helped you, please do like, share, and subscribe this channel. Thank you, and thank you very much.